Assalamu alaikum everybody, this is Khalil Houthi, your instructor in General Geophysics course. This is the first lab. In this video, we'll explain to you what you have to do and what should be submitted or uploaded to the module. Basically, I sent you a couple of files. The first one is the software itself called FastGraph. Then I sent you this Word document which explains few details of what you need to go through. Additionally, following my video, you will be able to complete the task. There are simply just two questions, question one and question two. The first question, basically, you need to upload or paste here a figure from the modeling results. In the second question, you need to fill this table with some parameters. Those parameters are from the bodies you create. So these two bodies are actually the targets you're gonna model during the modeling process. So how you start, these are the data, what you find, these are the actual data, that's what have been measured. So if I open it, I find that there are some columns. It's a text file. The first one is just explaining what is the file name. Then I have the X, Y, and Z. Since there is no change in X, I'm only having the X, and the X is from 0 up until 100. It means that this is basically a profile, straight line profile, and the profile length in meter is 100. So we have a reading at 0 meter. There is no reading from 1 to 4. The second reading is at 5 meters. It means the station interval is basically 5 meters. There are measurements in every fifth meter. Uh, so I gave you this file. You need to unrar it. What I mean by unrar, for example, extract here. If you have Windows, using Windows, you can extract it here. For someone who is using Mac, you can stay the same software from this website. So this is from where you can download it. They have a version for Windows and also a version for Mac. Since here I'm using Windows, I am Windows person, I go along with Windows version. For others who are having Mac, just get this one. So let's open it. First, I need, as I said, to unrar it or extract the files. Once I extract the file, I get another folder. That's the folder. If I go inside, you don't need to install anything, by the way. Just click on this application, executable. Click on FastGraph, executable. So open it. It's empty right now. There is nothing. So we need to bring the data we have. The data, as I said, are simply what you have seen here. That's the data modeling. Let's bring them to the software and start the modeling process. Where I go, I just need to click this one, add observation sets, add observation file, or observed data. Click on it, go to this file where you have the data modeling. That's the one, modeling. Open it. Set the acceleration in milligal. The acceleration value usually is in some other values rather than milligal. Here we set it in milligal. The most accepted value is usually meter per second squared. However, here we'll use only milligal. Distance, the distance gonna be in meter. That's the acceleration. Accept defaults. And since you got the data are here. These are the data observation sets. Here we create bodies or targets. You can create simple bodies or by some complex bodies too. For this task or this lab, you need to create basically two different bodies. One of them is a cylinder, the other one is a spherical. And these two options are available here. First one is spherical, the other one is cylindrical. I got the data, I have the data, here are the data. Then I need to create a cross section. To create a cross section to view your data, just click this button. Okay, so here I have the upper window represents the data, whereas the lower window represent the geological model. So I can, for example, the access for the model or geological model, I can go deeper, shallower. To view any set of data, to view the data you have, select them from here. Select it, that's the data. You get your data. So it looks like there are two anomalies. This is one anomaly, that's another anomaly. Another interesting thing, there is a reading each 5 meters. This is the first, second, and so on. So let's try modeling. We create a model of the subsurface, assume that this is what represents the subsurface, and the model needs some parameters. The parameters of the models are basically, if I'm doing gravity survey, is density of these bodies. So I will first create sphere. Let's assume this anomaly here is because of a spherical body I created. Give it a name, sphere. You can name it whatever you like. Let's give it a density. Let's assume this density is 4000. And let's give it a radius. And I give it a radius of 5 meters. So it has a density. This is basically the density difference. But for today, don't care too much about what is the relative density and the absolute density. Here, the value I'm providing is the relative density. Once we study the subject of gravity method, you will appreciate or understand what I mean by either relative density or absolute density. Give it a value of 5, a radius of 5, and click apply. So what I can do, I can drag it. So I can bring it here. This is a sphere. And I also create what I call cylinder. Add a cylinder, give it a density, let's say 3000 kilogram per meter cubed, and give it a name of cylinder and specify a radius. Let's specify a radius of 5 as well. Click apply. You can bring it here. So your task right now is play around with the location and the radius. You can increase, decrease the radius until these two curves matches. So the black curve actually are the observed data, whereas the blue curve is the calculated. So what shall I do? I can increase, for example, the radius. That's how I increase the radius. The radius kept increasing until I find that there is some kind of match between the two. And you can do the same thing here. Let's play around with these parameters until we get a good agreement between the two. So keep an eye. And if you want to edit again, if you want, for example, to edit the parameters of density and radius, double click on the body here, the name of the body. For example, I would like to increase the density of the cylinder. Double click it, make the density, for example, 5000, apply, and keep changing it. We try our best until we get a good acceptable match between the two. It's not always possible to get an exact match. You do your best. Let me change the density again. Make it, for example, 7000. Again, I'm changing. I'm trying testing different values. I make it 10,000. Right now, this is the distance, whereas this axis is the depth. Good. Let me try to decrease right now the number. Make it like 2000. I'm testing different values. What I can do, I can bring this one shallower, shallower. That's it. So this is an acceptable model. Not perfectly matching, but it's about acceptable. The cylinder is shallower to the surface. The sphere is deeper. These are two different bodies. If you want to get their parameters, this is from where you get the parameters. And uh, that's what you need to submit. First of all, for question one, go take a screenshot of this window. So I use a tool called snipping tool. That's the snipping tool I use. I take a screenshot of what I have here. That's the screenshot. I copy it, go back to here, and just paste it. That's what you need to do. Another thing is, for example, you need to bring the density of each body, the radius, and the depth. From where you get these values? Again, for example, for the radius, double click, that's the density. This is the depth, that's the depth. The Z is the depth. And finally, you need also to provide the radius of that body. Do the same for the sphere. You need to bring me the density, the depth, which is Z, and finally the radius. Type these values here. Once you finish, upload back, save this one, provide me with your name. Your name is what exactly? And the ID. Send these to or upload the file then to module. I will soon make a link module for you to upload the file. Mm, all the best then. Goodbye. Thank you very much.